Okay, students. Now we'll continue the types of organic reactions. Organic reactions. In this category or in this, we know about substitution reactions, second, addition reactions, third, elimination reactions, fourth, rearrangement reaction. Rearrangement reactions. Out of these four, we know already about substitution reactions, what they are, and what about the examples. Then about addition reactions, elimination reactions, and now today we'll concentrate on rearrangement reaction. Before going to that, let me recall about the three we already explained to you. Now, the first one, as you know already. So here, substitution reaction. Substitution reactions. Here, in one word, I can say an atom or group of atoms of a molecule were substituted by another atom or group of atoms. So that is ROH plus HX give rise to RX plus H2O. RX, here ROH. So that means OH is totally replaced by X. OH is completely replaced or substituted by X atom. Such kind of reactions, substitution. It is just like a cocoa cake where one person replaces the another person. That is what we call it as substitution reactions. In substitution reaction, there are many types. They are nucleophilic substitution reactions. Later on, when the first year begins, at that time, that means the syllabus begins, at that time you will come to know what is nucleophilic substitution reaction, what is electrophilic substitution reaction, what is free radical substitution reaction, all the details regarding this. These are the nothing but types of substitution reactions. Okay, now this is about substitution reactions. Second, about elimination reaction. Elimination reactions. Elimination reactions. In the elimination reaction, the word itself indicates removal. Here, removal of an atom or group of atoms from the molecule. That is what we call it as elimination reaction. So here in this, I'll take the example CH3 OH H. Here I will take Cl as an example and H. This we call it as ethyl chloride. Later on, that also we will come to know the names. Ethyl chloride. Ethyl chloride. Plus KOH. You know already, KOH is nothing but potassium hydroxide. And this is alcoholic, which is dissolved in the alcohol. Now, here K will take up this Cl and H will take up by this OH. So I will write those two products first. One is KCl, another one is H2O. Then what is left? Here CH2 is left. Here also CH2. So therefore double bond is there. The single bond becomes double bond. The single bond becomes double bond. So that is unsaturated compound is formed actually. Unsaturated compound is formed from a saturated compound. Saturated compound. So that means here we are removing hydrogen as well as chlorine from this molecule. We are removing hydrogen and chlorine from this molecule. So that is removal of an atom or group of atoms from the molecule. Here we are removing atoms from the molecule to give an unsaturated product. Such type of reactions we call it as elimination reactions. Such type of reactions are called as elimination reactions. So what are elimination reactions? As you know already, removal of an atom or group of atoms from the molecule. So that is about the second elimination. Here also you will find different types. That we call it as alpha elimination, beta elimination. That means different types are there. That also you can study or you will come to know in the regular classes. Okay, so that is about the elimination reactions. Next, addition reactions. Addition reactions. Addition reactions. What are addition reactions? Exactly opposite to that of elimination reactions. Exactly opposite to that of elimination reaction is addition reactions. What are addition reactions? The word itself indicates something is going to be added without disturbing the configuration of the molecule. Without disturbing configuration of the molecule, addition of something, then it is called as addition reaction. So that means, for example, if I take CH2, double bond CH2, this we call it as ethene. It is an alkene. To this, if hydrogen is added in presence of palladium or any metal, transition metal catalyst, for example, you can take nickel also. So here hydrogen, when it is added to this alkene, that is ethene, so this double bond breaks actually. And here C, H, 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 C, H, H and H. That means here we are adding hydrogen to the unsaturated compound, to form a saturated compound. In case of elimination reaction, saturated compound is going to convert it into unsaturated, but here unsaturated compound is converted into saturated one. And here we are adding an atom or group of atoms without disturbing. Here we are not disturbing the configuration of the molecule. Configuration in the sense atoms and their arrangement. So that is not disturbed actually. Without disturbing, adding the molecule is nothing but addition reactions. One such example, hydrogenation of alkene. You can say this as hydrogenation of alkene to form alkane. That is about addition reaction. Here also again different types of there. Nucleophilic addition reactions are there. Nucleophilic addition reactions. Electrophilic addition reactions. Different types are there again. Okay, so that is about the addition reactions. Now we'll see about the next point called rearrangement reactions. Rearrangement reactions. Rearrangement reactions. Rearrangement reaction. Here you just observe this example so that you will come to know what actually the rearrangement was there. C, H, H, CO, CH. This product we call it as acetone, or you can call it as propanone. Just I am showing how actually the rearrangement was taking place. So this is acetone. Now give rise to, you can shift this double bond over here. You can shift this double bond here, and you just replace or you just substitute or add or to arrange this hydrogen after this oxygen. Now we'll see what difference you will find. CH3 is not disturbed. Then C, the double bond is shifted over here, means I will put double bond here. Then this double bond will become now single bond. O is there, that is bonded with hydrogen because this hydrogen is moving toward this. Then here H and H. So that means what is rearrangement? Here the molecule itself rearranges to give different products. So what are rearrangement reactions? These are the type of reactions in which the atoms were rearranged or rebonded from one atom to another atom, or they are transferring from, they are moving from one part to another part to give a new product. That is what we call it as rearrangement reactions. So rearrangement reactions are those reactions in which either an atom or you can say the bonds are rearranged to give a new product. So that is what we call it as rearrangement reactions. That is about the rearrangement, and here this is what we call it as a ketone group, and this we call it as enol. Why it is called as enol? En means double bond. You know already in the SSLC, alcohol functional group is the name of functional group of OH is called as or called by OL. That's why it is called as keto-enol arrangement. Keto-enol arrangement. So that is about the rearrangement reactions. So what are rearrangement reactions? Are the type of reactions in which either the atoms or sometimes the bonds are rearranged to give a new product. So these are the different types of organic reactions. These are the different types of organic reactions. Now we'll see types of inorganic reactions. Very few are there. Inorganic reactions. Now let us see in detail about inorganic reactions. Okay, types of inorganic reactions. In broader sense, there is no demarcation that this is inorganic and this is organic, because sometimes an inorganic compound is mixed with organic molecule to give a product. But in narrower sense, or you can say at the preliminary stage, we can differentiate, but at higher level there is no such a demarcation. Okay, now types of inorganic reactions. Here also you can see substitution reaction, that we call it as displacement reactions. Displacement reactions. Displacement reactions. It may be a single displacement, it may be a double displacement, I will show you about single displacement. Here I will take Mg plus HCl give rise to MgCl2 plus H2. To balance this, 2 HCl is required, as you know already. So that means here magnesium replaces what? Displaces hydrogen. That kind of nature we call it as what? Single displacement reactions. Single displacement reaction. Only one atom displaced by another atom. Only one atom is displaced by another atom. Now, that is single displacement. What is single displacement reaction? First of all, what is displacement? It is just like a substitution reaction only, where one atom displaces another atom, or one group is replaced by another group. Now we will see single displacement, where only one atom replaces another atom. We will have double displacement reaction, that I will show you here. Here I will take BaCl2 plus AgNO3, BaCl2 plus AgNO3, BaCl2 plus AgNO3 give rise to here Ba bonded with NO3, so you are getting BaNO3 plus AgCl. That means here both the atoms, here also both the atoms, or you can say groups, will displace with one another. Here barium displaces silver, nitrate displaces chlorine. Such kind of displacement we call it as double displacement reactions. Double, two. So that is about another important example. And if you go with the balancing the equation, what is required? If you take 2 AgCl, that means 2 AgNO3, isn't it? Now BaNO3, okay, balanced it is. If I take 2, what happens? Let us see. That also we can go for that. So here BaCl2 plus AgNO3, before going to that, give rise to BaNO3 taken twice, because NO3 is -1, barium is +2. So therefore BaNO3 taken twice plus AgCl. Now we can balance. If I take 2, then I will put 2. So now NO3 is also 2, NO3 is also 2, 2Ag, 2Ag, 2Cl, 2Cl, balanced it is. Such type of reactions we call it as what? Displacement. Here double displacement it is single displacement. Like that you will find more reactions or more examples in this category. Okay, while explaining the topic now, while explaining the subject, at that time automatically will come to know what type of reaction it was, whether it is single displacement or double displacement, whether it is substitution or elimination or rearrangement. All these types will come while explaining the topics. Okay, so this is about displacement reactions. Now another point that is decomposition reactions. Decomposition reactions. The name itself indicates decomposition. Composition was removed. Composition was split up into parts, divided into parts. That is called as decomposition. So decomposition, D means removal actually. The word D refers to removal. Composition was taken out. One example, CaCO3 give rise to CaO plus CO2. That means calcium carbonate, limestone, on heating will give up calcium oxide and carbon dioxide. Such type of reactions we call it as a decomposition reaction. What is decomposition? Here composition of calcium carbonate is calcium oxide and carbon dioxide. So calcium oxide plus carbon dioxide fuse to form calcium carbonate. That means when calcium carbonate is decomposed, when it is strongly heated, it gives up into its constituents. Constituents means components from which it is going to be formed. So that is about the decomposition reaction. What are decomposition reactions? These are the type of reactions in which a molecule get converted into its constituents, its components from which it is going to be formed. So that is decomposition reactions. That is second type. Third, very important. It comes in both part. That is in organic as well as in the inorganic. That is oxidation and reduction. Addition of oxygen to the reaction is oxidation. Here we can take it as O2 or we can say nascent oxygen. Nascent oxygen means unstable, highly active atomic state of an atom is called as nascent species. What are nascent species? Unstable, highly reactive atomic state of an element. O2 is a molecular state. So addition of oxygen or nascent oxygen to the reaction is oxidation. Addition of hydrogen to the reaction is called as reduction. Here hydrogen or you can say nascent hydrogen. So addition of hydrogen or nascent hydrogen to the reaction is reduction. So that is the first definition of oxidation and reduction. Second one, removal of hydrogen from the molecule, from the compound is oxidation. Here, removal of oxygen from the molecule is reduction. So, removal of oxygen from the molecule is reduction. Removal of hydrogen from the molecule is oxidation. So, that is about the oxidation and reduction, two definition. Third, removal of, or you can say loss of electrons. Here, gain of electrons. Gain of electrons. These are the definitions of oxidation and reduction. Detail we'll see in the next class.